Welcome. You made it here. That's enough. Whatever the day held, whatever thoughts are still circling, whatever your body is carrying right now, you can set it down. You don't have to carry any of it tonight. Just let it rest beside you. Let it wait until morning. Take a slow breath in. Not a big dramatic breath, just a gentle one, like the room is breathing with you. And let it go. Again. In and out. Feel the weight of your head where it rests. Notice the surface beneath it. The way gravity is already doing the work. You don't have to hold yourself up. The earth has you. Let your jaw go loose. You might not have realized it was tight. Most people are. Let your back teeth part just slightly. Let your tongue rest soft on the bottom of your mouth. That's it. Your shoulders. Check in with them gently. They've probably been carrying something all day. Let them drop. Let them melt down toward whatever is beneath you. Even lower. A little more. There you go. Your hands can soften now. Let your fingers uncurl. Let your palms open just slightly, like something releasing a breath it had been holding. Scan down through your body slowly. Your chest, your belly. Let them rise and fall without effort. You don't have to breathe correctly. Your body knows how to breathe. It's been doing it your whole life without any help from you. Your hips, the backs of your legs, your feet. Let all of it be heavy. Let all of it sink. You're safe here. Nothing is required of you. There's nowhere else you need to be. Nothing you forgot that matters right now. Just here. Just this. It's okay if your mind drifts as we go. It's okay if you fall asleep before we're done. That would be a good outcome. That would mean it's working. Tonight we're going somewhere very far away. We're going to travel out past everything familiar. Past the moon. Past the planets. Past the edge of our solar system. And into the deep dark between the stars. We're going to the place where space itself gets strange, where time bends, where gravity wins. We're going to fall into a black hole. And I promise, there's nothing to be afraid of. It will be the gentlest journey you've ever taken. But first, we need to understand something. We need to understand where black holes come from. And to understand that, we have to go back, way, way back, to the beginning of a star. Take a breath. A long, long time ago. So long that the number doesn't really land in the mind, and that's fine. Just let it drift past. There was a cloud. Not a cloud like the ones that pile up on a summer afternoon. Not made of water or mist. A cloud made of gas. Hydrogen, mostly. The very simplest thing. One proton. One electron, barely there at all. This cloud drifted in the dark between galaxies, enormous, thin, barely anything, more space than substance. It had been drifting like that for a very long time, slowly, quietly, and then something changed. Maybe a distant star exploded somewhere far away and its shockwave rippled outward through space and nudged this cloud. Just slightly, just enough. Or maybe the cloud had simply been gathering itself for so long that it reached some tipping point. Because gravity is patient. Gravity never gets tired. Gravity just waits. And very slowly, over millions of years, the cloud began to fall toward itself. Each tiny piece of gas pulling on every other piece. The center growing denser. The gas warming as it compressed. Millions of years of this. You don't have to hold on to that. Just let it mean a very, very long time. Long enough that anything is possible. Long enough that something extraordinary can happen just by waiting. The core of the cloud grew hotter and hotter and hotter until one day, at some threshold, at some moment no one was watching, it got hot enough. hot enough for two hydrogen atoms to touch and fuse, to become helium, and in that fusion, a burst of light, and then another, and another, and another, like a match catching after a long time being held in the dark. The cloud ignited from the inside. A star was born. Something that had been nothing but drifting gas was now burning, was now shining, was pouring light in every direction across the emptiness. A star. Our sun is like this. Right now, as you breathe in the dark, the sun is burning 93 million miles away, fusing hydrogen into helium, moment by moment. It has been doing this for about 5 billion years. It will do it for 5 billion more. Let that be something soft and enormous in your mind for a moment. 5 billion years of just burning, of just giving light. Every star you've ever seen in the sky is doing this. Every point of light in the night, there's a sun there, with its own planets maybe, its own slow burning, its own billions of years. And none of them burn forever. That's the thing about stars. They are generous. They spend themselves completely. They burn through everything they have. And when a star starts to run low on hydrogen, very slowly, over millions of years, it begins to change. For a star like our sun, the ending will be quiet. The outer layers will expand. The star will grow cooler and redder, swelling outward, a red giant. And then the outer layers will drift away like smoke, glowing softly as they go, forming a beautiful ring around the cooling core, a planetary nebula. And at the center, what's left will be a white dwarf, a small, dense, slowly cooling ember, getting dimmer and cooler over billions of years, until it is nothing but a dark, cold whisper in the dark. There's something peaceful in that, I think. A star that burned for billions of years and then just let go. But for the very massive stars, the giants, the ending is different, more sudden, more complete. When a massive star runs out of fuel, gravity wins all at once. The core collapses in a fraction of a second. Everything falls inward with enormous speed. And then the outer layers crash into that collapsing core and bounce outward in an explosion of almost unimaginable scale. A supernova. A flash so bright it can outshine an entire galaxy for a moment. Billions and billions of stars all at once, and one dying star briefly brighter than all of them. And then the light fades, and the gas drifts outward, and where the star used to be, there is a kind of absence, an absence with weight. At the center of where the star once burned, all that mass, compressed, collapsed, crushed down past any boundary we understand, has become something new. A singularity. A point. We don't have words for how small. We don't have words for how dense. Our mathematics breaks down when we try to describe it. Our equations produce answers that don't make sense. And that's a sign. Not that physics is wrong, but that we've reached the edge of what physics currently knows, which is its own kind of wonder. Around this singularity, at a specific distance, the distance at which the escape velocity reaches the speed of light, there is a boundary, not a wall, not a surface, just a place in space, a threshold. On one side, things can still escape. Light can still travel outward. A spaceship could still turn around. On the other side, nothing can leave. Not light, not information, not anything. This is the event horizon. And together, the singularity and the event horizon, this is a black hole. Let that settle. A black hole is not a hole in space. It's more like a place in space where gravity has become so strong that the rules we're used to no longer apply. It's invisible. Black holes don't shine. They don't glow. They make themselves known only by what they do to the things around them, by the way they bend light, by the way they pull, by the way they change time. We'll come back to that. First, let's go there. Let's drift toward one. Close your eyes a little more. Let your body get heavier. Imagine you are floating, not falling yet, just floating. Weightless in the deep dark, completely still. The universe around you quiet and vast. Far ahead, you can't see the black hole itself, but you can see what it does to the space around it. The stars behind it look wrong. They're bent, smeared, stretched into arcs. Because light doesn't travel in straight lines near a black hole. It follows the curve of space. And the black hole curves space so dramatically that light coming from behind it wraps around and arrives at your eyes from angles it shouldn't. You can see stars that should be hidden behind the black hole. You can see them displaced, appearing above and below, and to the sides. Some stars appear twice, their light taking two different paths around the darkness and arriving separately. And at the center of all this bending, a circle of absolute black. Not dark like night, not dark like a closed room. Dark in a way that feels final. A perfect circle of nothing, surrounded by a halo of gathered compressed light. The photon sphere, the place where light itself orbits, endlessly circling, going nowhere. And around the edges, farther out, the accretion disk, a slow, luminous swirl of gas and dust, and the remains of things that got too close. Heated by compression and friction to temperatures no laboratory on Earth can match. Glowing amber and gold and blue-white, drifting like a slow river around the darkness. It is, in its own way, the most beautiful thing. It is a star dying by inches, giving its last light in a slow spiral into the dark. And you are drifting toward all of this. Not fast, not violently, just drifting, the way you drift towards sleep. Your breath is slow, your body is heavy. The pull of the black hole is gentle at first, you barely feel it. Just a direction, just a leaning. As you drift closer, something begins to happen to time. This is the part that Albert Einstein spent years thinking about. He liked to run thought experiments, imagined himself riding on a beam of light, imagined what it would look like to fall freely in a gravitational field. And what he discovered, what he worked out mathematically, and what has since been confirmed again and again by experiment, is that time is not fixed. Time is not a river flowing at the same rate everywhere. Time is more like fabric, and gravity warps that fabric. The stronger the gravity, the slower time flows. We've measured this here on Earth. Clocks at the top of a tall mountain tick slightly faster than clocks at sea level. GPS satellites have to account for this difference, or they give you wrong directions. It's real and measurable and strange. Near a black hole where gravity is incomprehensibly strong, this effect becomes enormous. Imagine someone watching you from far away. Safe. Distant. Looking through a telescope. They see you drifting toward the event horizon, getting closer and closer. And as they watch, they notice something strange. You appear to be slowing down, not in space, in time. The closer you get to the event horizon, the slower time moves for you relative to them. As you approach the boundary, their clocks tick faster and faster compared to yours. Seconds for you become minutes for them, then hours, then days. At the very edge of the event horizon, from their perspective, time appears to stop completely. They would see you frozen, a still photograph, suspended at the threshold forever. But you feel nothing unusual. No alarm, no warning. Your heartbeat continues at the same rate. Your thoughts move at the same pace. From your perspective, you simply drift across. You cross the event horizon, quietly, without announcement. You might not even know it happened. The stars behind you shift. The whole sky compresses into a circle of light at your back. All of the universe outside gathered into a bright disk, growing smaller as you descend. Ahead, there is depth. There is quiet. You are inside now. Inside the event horizon. Inside the place physics calls a black hole. And here, inside, no one knows exactly what there is. That's the honest answer. That's the beautiful, strange, humble answer. Our equations reach a point and then they stop working. They produce infinities. They produce divisions by zero. They point towards something and then fall silent. Some physicists believe the singularity isn't truly a point, that our math simply doesn't have the right language yet, that there is something there, some structure, some geometry, that a future theory will describe. Some believe information is never truly lost, that everything that ever fell into a black hole, every particle, every pattern, every memory encoded in matter, is somehow preserved, written on the surface of the event horizon like information on a vast, curved screen. Stephen Hawking spent decades working on this question. He showed that black holes are not completely black. They emit a very faint, very slow radiation, caused by quantum effects at the event horizon. We call it Hawking radiation. It is so faint, it has never been directly observed. But the mathematics suggests it's real, and it means that black holes, given enough time, unimaginable amounts of time, eventually evaporate. They slowly lose mass. They slowly shrink, until finally they are gone. And everything they ever held, somehow in some form we don't yet fully understand, is released. Your atoms, the light from your eyes, the pattern of who you are. Given enough time, it returns to the universe. Nothing is truly lost. Let that be a comfort, if it can be. But right now, you are still falling, still descending. There is no floor coming. There is no moment of impact. This is one of the strangest and most peaceful truths about falling into a black hole. Inside the event horizon, all paths lead toward the singularity. There is no direction that leads away. Even if you fire your rockets, even if you turn around and push with everything you have, you cannot stop falling. And so, you don't try. You just fall, slowly, gently. The universe behind you has become a small, bright circle. Everything you've ever known compressed into a disk of light at your back. And ahead, just depth. Just the long, quiet fact of falling. This is the part that surprises people. Falling forever doesn't feel like falling. It feels like floating. Because there's nothing to fall against, no wind, no resistance. Just the smooth, continuous pull of gravity that you can't feel any more than you can feel the earth pulling you right now as you lie there. You are always falling toward the earth. The earth is always pulling you. You feel it as weight, as pressure, as the sensation of the mattress beneath you. But inside a black hole, in freefall, even that goes away. It is the most complete weightlessness, the most complete stillness, just falling through the dark, toward a destination that never arrives. Some calculations suggest that for a black hole of sufficient mass, the fall to the singularity would take a very long time. Long enough to rest, long enough to dream. And here is the strange gift inside all of this. There is nothing to decide. There is nowhere else to be. There is only the falling, and the falling is fine. The falling is, in its own way, the most restful thing in the universe. No destination, no arrival, no decisions to make. Just the long, slow, endless descent through the dark. Come back now, very slowly, back to your body, back to the weight of it where it rests. The black hole is still out there somewhere, billions of light years away, falling forever without you. But you are here, in your bed, in your body, in the dark, and you are falling too, not through space, into sleep. It happens the same way, slowly at first, then all at once, a drifting, a sinking, a letting go of the edges of things. You don't have to do anything. You don't have to remember any of what we talked about tonight, not the star, not the singularity, not the event horizon. Let it all blur and soften. Let the details dissolve. What remains is this. You are held. You are safe. Gravity has you. The universe has you. And you can fall now, as far and as long as you need. There is no bottom, only depth, only dark, only rest. Good night.